Okay, so continuing on with this discussion about the kind of unintended consequences in some cases of technological development in the early industrial revolution, left off talking about just how impactful something like the cotton gin was, and how in many cases it um, uh, had this ironic twist to it, um, as far as trying to, instead of diminishing dependency on slavery and the institution of slavery, instead it actually spurred and drove an increase in the importation of slaves. It's important to understand that before 1793 or by the late 18th century, in many cases or in many respects, the institution of slavery was uh, in question by not only uh, members of American society, but then also by some plantation owners themselves, as far as the profitability coming from depending on enslaved labor. But with things like the cotton gin, for almost overnight, um, plantation owners began to realize and unlock the economic potential of their enslaved labor. And so, as a result, between 1793, and 1808, when the United States government officially outlawed the international slave trade, the importation of slaves from Africa, um, there was actually a um, recovery, a rebound, and a growing demand for slaves from Africa, largely as a result of the economic windfall that many plantation owners were enjoying. Again, largely as a result of the technologies that they were beginning to fuse with their enslaved labor, again, to maximize profit for themselves. That's the kind of scope of interconnectivity and the relationships that begin to develop with regard to technology, industrialization, and more established ancient types of practices like the institution of slavery itself. How much were textiles and raw materials for the textile industry in demand? Well, to give you some statistics here, in 1760, Britain imported some 2.5 million pounds of raw cotton per year, um, which was by during that time largely processed mainly via cottage industry types of arrangements. By 1787, Britain was importing 22 million pounds of cotton, almost a tenfold increase. And by this point, it was beginning to be spun increasingly on machines. By 1840, Britain was importing 366 million pounds of cotton per year, coming from around the world, not just the United States, but other parts of the world as well. And so it shows you the truly exponential growth and demand for raw materials like cotton in particular. And that was not unique simply to the textile industry. Other industries included the likes of heavy industry as well. And this was largely due to the amount of refinements and improvements that were being made to the processing of iron ore in particular. Um, Very quickly, it was the mastery of exposing ore, metalled ore, to higher temperatures would result in a higher quality product. And so higher temperatures can burn away the impurities, the embedded impurities within the ore itself. And so what happens is that you remove more of the impurities and you produce more of a stronger, higher quality metal coming out on the other end. And so as a result, there would be, because refinements and improvements were made in the processing of the ore itself, this would lead to an increased demand for iron being extracted. To give you again some statistics here, in 1740, Britain was producing about 17,000 tons of iron per year, just about a decade before the actual arrival of the Industrial Revolution. 40 years later, by the 1780s, Britain was producing about 70,000 tons. By the 1840s, Britain was producing 2 million tons of iron ore. And by 1852, it was producing just just shy of 3 million tons, which was more at that point than the rest of the world produced combined. So, in the matter of about a 10 to 12 year span, um, Britain alone was producing a million tons more iron than it was just than a decade or so prior, and it was eclipsing the rest of the world combined. So again, this gives you a pretty explicit idea as to how lucrative and how far ahead Britain was with regard to the rest of the world when it came to industrialization. Other key inventions included things like the introduction of steam technology. This is largely due to the innovations and refinements made by James Watt, who is a Scottish engineer. He was able to successfully make refinements to existing machinery that had originally been invented to pump, uh, no, excuse me, to serve as the world's first steam pump to extract water out of mines that were tunneling deep within the earth and in England beneath the water table. So, what that means is that in England, you might have mines, but then when you got to a certain threshold, the water table was had come up to such a point that miners could no longer get at the seams of coal or iron ore because they couldn't remove the water fast enough to continue the mining process. When James Watt introduces his refines existing machinery in order to create the first steam pump. This means that the steam pump itself can extract water at such a rate that it can artificially lower the water table enough for miners to continue to burrow deeper and expose those seams of valuable iron ore and or coal or whatever else was being extracted. What this meant is that between 1815 and 1850, coal production in England quadrupled. Backing up a bit here, um, by 1782, Watt was making refinements to his steam pump, and instead of making it a vertical type of orientation, he instead set it on its side, creating um, a the piston necessary for driving a steam engine, which gets us into locomotion. Steam could be used to drive machinery, and steam engines essentially were tireless. That is going to very rapidly replace horsepower, horse-drawn carts or wagons or what have you. And of course, this engine would be fueled by coal. So you'd have a drum in which there would be a fire. The fire would be fed with coal to keep the fire going and to achieve temperatures that would boil water in a separate container, usually located above it. That water would turn to steam. The steam would drive the piston. The piston would be drive an axle that the wheels would be attached to, and therefore you have um, locomotion. And of course, this was fueled by coal because it was the fuel that England had in abundance. By the year 1800, Engines were generating some 10,000 horsepower. Just half a century later, by 1850, engines could achieve and generate some 500,000 horsepower. And some locomotives could even produce as much as 790,000 horsepower. So, again, the return on investment as far as these types of technologies spoke for itself. This had tremendous consequences, as you might expect, on transportation and the infrastructural development of Britain as a whole. Now, Britain was even better at getting goods to market more quickly. And this became imperative. Using these types of technologies and transportation systems became imperative to remain competitive. Companies and businesses began to band together to fund road construction, railroad construction, um, and this is where we see the introduction of things like tolled roads and turnpikes, so that you have so with the use of turnpikes, the businesses could collect fees for those that were using those roads that they had constructed, and kind of use it to offset the expense of building them, but also maintaining them uh, for future use. There were also canals that were built to maximize the use of Britain's many rivers, again, to kind of, again, stitch the countryside together more efficiently and rapidly. But it was going to be the incorporation and the expansion of railroads that would be the preferred mode of travel throughout the Industrial Revolution. This was indispensable to the oversee the industrial growth and economic development of the country as a whole. Steam powered locomotives emerged as early as 1804 when Richard Trevithick constructed the first such railroad in South Wales. That railroad itself was able to haul approximately 10 tons of ore and up to 70 people at a about 5 miles an hour as far as pace was concerned. By 1830, you have the opening of the first public railroad. This was largely due to the efforts of George Stephenson. Um, he named his locomotive the Rocket, which was able to transport people and goods between Liverpool and Manchester an astonishing 16 miles per hour. By 1840, Britain had almost 2,000 miles of railroad track laid, and by 1850, just a decade later, Britain had almost 6,000 miles of railroad track available for use. Railroads, of course, signified the growing maturity and complexity of the Industrial Revolution itself. Britain became home to an advanced civil and mechanical engineering corps, who the professions there, building a number of projects, um, able to create the bridges, grade the land properly for safe transit of things like railroads, among others. The construction of railroad bridges, in particular, and tunnels, gave humanity mastery over nature and the obstacles encountered as never before in human history. A sense of power and optimism came alongside the industrial growth that took place as well. That humanity was, in essence, unstoppable. Railroads created new opportunities for new labor and investment. Not only railroads, but all economic activity associated with railroads also grew as a result. That if you're able to move larger and larger quantities of goods across, considerable distances more quickly, more efficiently, of course, then this is going to help minimize costs, and therefore products would remain competitively priced. There was also the burning of fossil fuels. Again, coal burns hotter and longer You also needed to use things like petroleum, oil-based products in order to keep moving parts within a mechanized engine lubricated. So there were going to be increasing amounts of refinements made and products used in order to, keep the engine of the industrial age humming along. Adjusting to the industrial age was not easy for many rank and file members of society. Again, time and time management become more and more of a concern for the captains of industry, but also for virtually all members of the society as a whole. Pre-industrial societies, and I kind of alluded to this earlier in the lecture, but pre-industrial societies again worked largely irregular hours. Um, let's continue working here. There we go. Especially, this is especially the case for agricultural workers, that you have intense periods of work followed by uh, long periods of rest or inactivity. I mean, once the harvest was in, or you could begin to turn attention to other tasks. Um, in the off season, you could begin to either begin to turn attention towards the next season, or perhaps towards, maintaining property, or upkeep, maintenance on various kinds of tools or items needed. Factory life, in opposition, really began to shift attention towards a greater regimentation of time, a greater discipline being enacted as far as the managing of one's time. That there was a need, as I mentioned before, to set hours of work, uh, set various shifts of work, because the machines themselves could work tirelessly for long periods of time. This meant that to get the maximum output, this from the machines, human beings often had to work in various shifts in order not to become exhausted themselves. So workers were having to conform to the machine's needs and management's needs for maximum output. So they're losing a measure of agency here and self-determination. The work itself was largely becoming more repetitious and monotonous. Again, you're overseeing the operation of these machines, and because of that, you didn't have to rely on skilled labor in order to do that. And so non-skilled labor was oftentimes tapped into as far as serving as these operators of these machines, because it's the machines doing the work, not the humans. When you begin to make use of non-skilled workers, this means that you can pay them less because they don't need any special skills in order to win the job in the first place. Uh, Also added to this fact was that women and children were often used as sources of labor as well. In combination, what this means is unskilled labor, the use of women and children often meant that employers, business owners, could keep wages low, as opposed to employing skilled labor, because you're hiring somebody for a specialized set of skills oftentimes. But unskilled labor, you know, you basically showed them the general operation techniques, and that was pretty much it as far as on the job training. When it came to the use of children and women, this could be across the full gamut of any type of industry. So, typically you might think of women and children being used in the textile industries primarily. Not so much the case. Women were also used in mining. Um, uh, and so, and oftentimes, of course, women and children were paid less than their male counterparts. All of this in combination maximized profits for the industrialists themselves. And work days were pretty arduous, between 10 and 12 hours long, sometimes as often as 6 days a week. Workers transitioning to more of a factory oriented system and more of a regimented work schedule were poorly disciplined in this period of transition in the early years of industrialization. Oftentimes, there would be prolonged or substantial tardiness, drunkenness. People would be drunk on duty. And this could result in a number of punishments. Either fines would be levied against employees, or they could be dismissed. They could be fired for their infractions. And this could result in kind of a catalyst like effect in that if head of household lost their job, this could lead to economic ruin, not only for the worker, but for his or typically his, but oftentimes his or her entire family. And because we're talking about non skilled labor, you could easily replace one worker with another because you're not relying on the workforce to have any skills whatsoever. Children employed as child labor were beaten for workplace infractions. Oftentimes, they were employed for their size, that they could get into, kind of nooks and crannies of machinery to retrieve, items that had either, fallen or get into places to maintain machines and what have you. And this was there was a substantial hazard in the workplace as well. I mean, these machines oftentimes were unforgiving as far as improper use or any type of accidents on the job were concerned. So adjusting to the industrial age was quite um, disorienting for many within the workforce itself. Now we'll turn attention and kind of begin to close out this lecture talking about the industrialization process outside of Britain. So there were certain hurdles that the rest of Europe had to overcome, or at least endure, when it came to industrializing on the continent itself. First and foremost, there was a more conservative mindset, and I mentioned at the outset how Britain's one of Britain's uh, uh, kind of um, alluring characteristics was that it was able to and willing to on risk, willing to accept risk. Much of the rest of the Europe was not, and this hurt capital investment. There was a much greater emphasis on maintaining the status quo, an aversion to change. There were also anti-competitive practices that were in place, which benefited established sources of wealth. And also there was political instability. The French Revolution from 1789 and beyond, from 1789 to about 1812, where you have the French Revolution era and then also the Napoleonic Wars, provided for almost 2 decades worth of instability that from which the entirety of continental Europe suffered. Um, when Napoleon came to power, and we'll talk about the French Revolution and Napoleon in subsequent lectures, but when Napoleon came to power and he ran roughshod over continental Europe, he instituted what's known as his continental system, which essentially turned its back on Britain just at the moment when Britain was beginning to really double down on its industrialization and industrialization was accelerating the commercial interests of Britain itself. So, right when continental Europe really kind of potentially could have benefited from exchanges of knowledge with regard to industry, was exactly at the moment when continental Europe turned a cold shoulder to Britain in many respects. Industrialization, therefore, did not arrive on the continent of Europe in earnest until after the year 1815, after the Napoleonic era had run its course. The mainland looked to copy Britain as quickly and to as great an extent as possible. But Britain safeguarded its intellectual property. It instituted policies such as the one in 1825 when British artisans were restricted from leaving Britain. They didn't want their kinds of inventions or ideas to be copied elsewhere. Up until 1842, important machine parts and machines themselves could not be exported either. And so as a result, there was a good deal of industrial espionage that took place, the kind of secret movement of blueprints and so on and so forth that occurred in the early portions of the 19th century in order to allow for places like continental Europe and elsewhere to try and catch up with Britain. Technology spread gradually nonetheless, and this is akin to the spread of ideas. It's very difficult to police the spread of ideas as it is to police the spread of technology. So, moving forward, again, specifically after 1815, France, Belgium, and the Germanic states began to industrialize, which led to the further spread of innovation itself. There was in these areas of Europe growth of technological schools to help educate and promote, kind of engineering and mechanization and the study thereof. There was also political developments that were designed to help encourage industrialization. So in England, as you recall, industrialization grew independent of government to a large degree. It operated more along the lines of free market, laissez faire principles. On continental Europe, there was a very different approach. Government instead here played a larger role, a greater role. The government subsidized the cost of providing technical educations. The government also awarded grants to inventors and foreign entrepreneurs to relocate to continental Europe in order to help encourage industrialization. The government also was the one behind building key pieces of infrastructure, whether it was railroads, bridges, roads, port facilities. It was not; these were not projects that were sponsored by the private sector, as they were more inclined to be in Britain. What does that mean? Well, if you design the infrastructure and you have the government build it, then the government is going to be the one, it's going to be allowed for public access to use. And there wouldn't be the levying of internal tolls or turnpikes, the collection of fees for private interests. Since the government built it, all of the public was going to benefit from its use and reap the rewards. I'm almost out of time here. Let me just double check on the time. Okay, so yeah, I think I can get through tariffs, um, and then I'll pick up with the remaining part in the last segment, part three. So, government also, continental European governments also created protective tariffs, a tax that was placed on imported foreign goods in order to raise the price of those goods. This was done to help encourage buyers to purchase domestic made products. Revenue from the tariffs could spur additional public investment in industrialization and infrastructure. And it also kept cheap British goods from flooding foreign markets, continental markets as well. So I will pick up there in part three. Bear with me.